Arrays, just like any other variable type, can be passed in as arguments to functions. They can also be returned as return types. Say, for example, we want to create a function that calculates the average temperature from an array of temperatures. Let's name our function calculateAverage. It will take in an input of an array of doubles, and it would return a single double, which is the average value of all the doubles in the input array. So our function definition would look something like this: public double, calculateAverage, and a parameter of an array of doubles, which is called temperatures. The first thing we need to do is figure out how many temperature values are stored inside this array. Because they're passed in as a parameter, we don't really know how many elements are stored in it. To figure that out, we could type in the array name followed by the keyword length. This basically counts the number of items inside that array and stores it into our variable size. Next, to calculate the average, we need to add up all the items inside the array first. We can do that by declaring this total variable of type double and initialize it to 0. And then we follow that with a loop. Our loop counter I starts from 0 and keeps going as long as I is less than size, which we've calculated earlier. Now inside that loop, we could continue to add to our total variable the temperatures of I. Notice how I've used the loop counter as our index in our array here. This is basically because our loop counter starts from 0 and keeps incrementing by 1 every time, which means using this inside the loop, we're accessing every single item in the temperatures array. And because we're adding it to our total variable, by the end of this loop, total would have the total sum of the values inside this temperatures array. To calculate the average then, we just need to divide that by our size, which is the number of elements inside the array. And then we could safely return our average calculation as the result of our function. That looks great. Let's trace it with an example array of doubles to see if it actually works. If temperatures was equal to this array here with those 4 different temperatures, then once we start calculating the length, it would set our size to 4 because we have 4 different values there. The next step is to initialize total to 0, and then we step into the loop. Let's draw this table here and keep track of our loop counter, what it's accessing inside the array, and the updated total value every step. The first thing that happens is initializing I to 0, so I becomes 0. And because I is less than size, which is 4 in this case, so we step inside the loop and run this statement here. What happens inside the loop is we're trying to access temperatures of I. I is 0 at this case, so we're trying to access temperatures of 0, which is the first item in the array, which is equal to 75. So once we get that value, we add that to total because we're using the plus equal sign here. And total was initialized to 0, so once we add 75 to 0, total becomes 75. And then we reach this closing brackets of our loop, so we go back up and increment I. Once we run the increment I instruction, I increases by 1 from 0 to 1. The next thing that happens is we check if I is less than the size. I is 1 and size is 4, so that means we're allowed to step inside the loop. Inside our loop, we're accessing temperatures of I, which is now 1, and temperatures of 1 is equal to 73. So in that case, we're accessing 73. And then we're adding this temperatures of I to total using this plus equal sign, so we're basically adding 73 to 75, and total gets updated to 148. Again, we'll reach this closing brackets, so we go back up, increment I by 1, making it from 1 to 2, and then we go back and check if I is less than size. Size is 4, so that's still true, so we step inside the loop again. Temperatures of I at that point is temperatures of 2, so that's the item of index 2 here, which is 72. And then we're adding that to our total. So we're updating total from 148 to 220. We reach the closing bracket, go back up, increment I from 2 to 3, and then we're comparing it with the size, and 3 is still less than 4, so we step inside our loop, access our temperatures of 3, which is 80 at that point, and add that to total, making it from 220 to 300. And then at the last iteration, once we get this closing bracket, we go back up, increment I, which makes it 4, but now 4 is no longer less than size. So we do not step into that loop, and we basically just jump all the way down to the closing bracket down here. Now that we're done with the loop, we calculate the average by dividing total with size. Total ended up being 300, and size started as 4. So 300 divided by 4 becomes 75. And that's the value that gets stored into the variable average, so we can safely return that as the result of the function. Knowing the size of the array is very handy in many occasions. We've seen how to use it as the upper limit in a loop, but there's a more serious problem that could happen if you just ignore the size of your array. Imagine we're accessing different numbers in this array here. We know that it has 4 numbers in it, which means the indices start from 0 all the way to 3. And we've already seen how we can detect the number of items in an array using the length keyword. So if we run this statement here on this array, then length would actually calculate there to be 4 items and size becomes 4. But say we ignore this size variable and try to access the item with index 10, which obviously doesn't exist in the array. Once you try to run this program, Java would give an error saying that this index is beyond the bounds of the array. But since we have this variable size now, we know how many items exist in the array. And adding something as simple as this if condition around this print line statement, we can check if the number of index that we're trying to access is indeed smaller than our size. So in a case where the array looks something like this if condition would evaluate to false and it would not run this statement at all. However, if another array had more than 10 items, then this if condition would actually evaluate to true, and this statement would print the 10th item normally. Always be aware of your array bounds. The first thing you should do when dealing with arrays is try to figure out how many items are in there, and always check before accessing any item if it's within the bounds of the array or not.